Section 14.2, parabola. Okay, so suppose we're given some line. We'll call this line the directrix. And suppose I'm given some point. We'll call this point the focus. Then the locus of all points equidistant from this fixed point, called the focus, and this fixed line, called the directrix, is called a parabola. And so if you take, they got rid of all these. If you take any point on the parabola, then these two distances are the same. The distance from a point on the parabola to the focus and the distance from a point on the parabola to the directrix. If I take a line passing through the focus perpendicular to the directrix, this will be called the axis of symmetry. If I take a point intersecting the axis of symmetry and the parabola, this will be called the vertex. So suppose that we have a parabola suppose I have some parabola and that this is relative to some coordinate system and such that the vertex, well, and so this is some parabola with focus on the y-axis. Say that this is at the point 0, C. Suppose that the directrix is y equaling negative C. Here C could be positive or negative. I'm just sort of drawing them as if C were positive, but I'm not really using that fact other than making it look like a nice drawing. Actually, why don't I use, rather than C, maybe I'll use P. Maybe I'll use P here. And so this will be negative P. Okay, so let's try to determine. So notice that since the distance here, since the distance from the focus to a point on the parabola is the same as the distance from the point in the parabola to the directrix, then the distance from the focus to the vertex here is the same as this distance from the vertex to the directrix. So therefore, the vertex is the midpoint here between this focus and this point of intersection of the axis of symmetry and the directrix. And so, in this case, the vertex will be at the origin. Okay. So now, let's try to determine the equation of the parabola. And so let's take some point on the parabola. Let's say the point xy, and see what equation it satisfies. And so this distance here should be the same as this distance. Oh, it doesn't look the same, but uh, you know, if my graph was a little bit nicer, they would be the same distance. So let's find this distance. Oh, great. Let's find this distance and this distance here. So notice that since this is perpendicular to the line y equal negative p, then this point here must be the point x negative p. So let's try to determine the, well, square distance. And so let's figure out each of these distances. Maybe I'll call them d. They're all the same. And so the distance squared, I'll use the formula, is just, x2 minus x1 squared plus y2 minus y1 squared. D squared equals. Okay, so let's figure out what the actual distance is from the point, from the focus to the point on the parabola. And so it's just going to be x minus 0 squared plus y minus p squared. And for the and so that's this first distance here. Let's figure out this next distance here. And so it's just going to be x minus x squared plus y minus a negative p squared. And so these two distances are the same. So x minus 0 is just going to be x squared plus y minus p squared equals x minus x is just 0 squared. Let me square both sides of my equation. And so I get x squared plus, so if I square this, I get y squared minus 2py plus p squared equals square both sides, square this, and so y squared plus 2py plus p squared. Let me subtract p squared from both sides of my equation. Let me subtract y squared from both sides of my equation. Let me add 2py to both sides of my equation. And so I get that x squared, everything here cancels, is equal to 4py. And so that is the equation for a parabola whose vertex is at the origin and whose focus is on the y-axis at the point 0p. So similarly, if I happen to have a parabola with vertex at the origin, center at, say, P0, focus at P0, with vertex at the origin, the x-axis being the isosymmetry, and the directrix being x equal negative p. So that's my directrix. Then the equation for this parabola would be y squared equals 4px. So, in general, if you have, say, a vertex, I'm sorry, let's do the, so if the vertex is at hk, if the focus, let's say, is h plus p, k, and the directrix is at the point, let's say, y equals k minus p, then the equation of that, so all that we've done here is we've just moved this over, translated by hk. Then the equation of your parabola will be x minus h squared equals 4p y minus k. And lastly, if you have your vertex at hk, your focus at hk plus p, and the directrix is at x equal h minus p, then the equation of your parabola is y minus k squared equals 4p x minus h. And that is the equation of your parabola. And so those are the equations of your parabola. Let's, so I guess, when would you see a parabola? So examples of parabolas. So first, if you have something you throw it, then this object is going to have some sort of parabolic arc. Of course, this is really assuming that there's no air to resist. Then it looks like a parabola. Next, suppose you happen to have some sort of comet or something that comes in once, then it could be going along a parabolic arc. Okay. Another is, well, suppose you happen to have, well, this is supposed to be sort of a house, and on the roof of your house, I guess, I'll have it on the roof of your house, you happen to have, let's say, DirecTV or something. So you happen to have this dish, And so, oh, let's say dish TV. Okay. Well, if you look at the antenna for dish TV, it actually looks like a parabola, and it's actually a paraboloid, being the fact that it's not only it's a parabola sort of in every way you slice this sort of thing. So it's a parabola in 3D. And if you look up here, they'll have a little like ball up here, and this little ball will be at your focus. Similarly, if you happen to be looking at radio telescopes or whatever, so actually the radio telescope will look the same thing. It'll be some sort of, and that's your radio telescope. Or okay, so those are examples of where you'd see problem. Oh, of course, the most famous. Don't know if I can draw this, but which looks like a there. Okay, and so if you look here in your eyeball, so let's look at here. And so if you look at your eyeball, um, so there's your eye or something. It has this uh, lens, and well, this lens here actually looks like a parabola. It's very, of course, it's not that big. It actually looks so there's some sort of parabola here, and so it's actually in both directions. And actually back here too is a the back of it looks like a parabola. Okay. Okay, so let's do some examples. On page 591, let me do problem number 2. So I have f of x equals 3x squared plus 2. And so you're supposed to graph this. So let me replace f of x by y. If I subtract 2 from both sides, I have y minus 2 equals 3x squared. And so this actually is a translation of y equal 3x squared. And then divide, so translate this 2 units up. And then let me divide by 3. And so I have here y over 3 equals x squared. And so I'm going to stretch the y-axis by a factor of 3 for the graph of y equal x squared. And so if I look at this, I have here the graph of y equal x squared. I'm going to stretch the y-axis by a factor of 3. And so I have here the graph of y equal 3x squared. And now let's move this up. So I should have said that I scaled this by a factor of 3. So this will be done by 3. Next, let me move this up by 2 units. And so I finally get the graph. And so this is the graph of y equals 3x squared plus 2. Let me do problem number 14. F of x equal x minus 3 squared minus 7. In exercises 13 through 48, find the coordinates of the vertex and the equation of the axis symmetry. Okay, so the vertex the axis symmetry is found by just setting the x minus 3 equal to 0. And so the axis symmetry is just x equal 3. The vertex is found by, well, I know the x coordinate of the vertex by just plugging in the what the x value is for the axis symmetry. Let's find the corresponding y value. Well, f at 3 is just going to equal negative 7. So that's the y coordinate of the vertex. Let me do problem number 16. F of x equal negative 5 x plus 1 squared plus 1. And so let's determine the axis of symmetry. The axis of symmetry is found by setting what's inside the square equal to 0 and solving for x. So x is equal to negative 1. Let me determine the equation of the value of the vertex. And so let's determine, so the x coordinate of the vertex is at negative 1. The y coordinate of the vertex is found by replacing x by negative 1 and solving. Well, negative 1 plus 1 is 0. Squared is 0 times negative 5 is 0 plus 1 is 1. Let's do problem number 28. F of x is equal to 2x squared plus 6x minus 1. Okay, so let's try to determine the axis of symmetry. Well, if you recall, the axis of symmetry is just equal to a negative b over 2a, which is equal to a negative 6 over 2a. I can divide each of these by 2, so I get a negative 3 halves. And so x equaling negative 3 halves is your axis symmetry. And so the vertex will be at -3/2. And let's figure out the corresponding y-coordinate. And so f at -3/2 is equal to 2 times -3/2 squared plus 6 times -3/2 minus 1. -3/2 squared is 9/4. Question. Oh, you got lost there. Sure. So this is the equation for vertex, for the axis symmetry. So the equation for the axis symmetry is just x equal -b/2a. And so if I look here at my quadratic, it is in the form, if you recall, of ax squared plus bx plus c. So a in this case is the number in front of x squared, 2. B in this case is the number in front of x, 6. I can divide both the numerator and denominator by 2. And so I get a -3 divided by 2. Got it. Okay. And so now I just plug in the -3/2 for x into the f formula, the formula for my function, and then determine what the corresponding value is. And so positive times negative is negative. 3 times 6 is 18/2 minus, let me get a common denominator. Let's multiply and divide by 2. So minus 2/2. 4 divided by 2. Oops. 4 divided by 2 is 2. So therefore, 9/2 minus 18/2 minus 2/2 is, a -11/2. And that is, those are the coordinates of my vertex. Let me do problem 48. Let me do problem 48. F of x equals 4x squared minus 2x plus 1. And so the axis of symmetry is found by using the formula x equal -b/2a. b in this case is a -2. A is 4. And so negative divided by negative is positive. The 2's cancel. And so x is equal to 1/4. The vertex is, well, the x-coordinate is 1/4. The corresponding y-coordinate is, well, f of 1/4 is equal to 4 times 1/4 squared minus 2 times 1/4 plus 1. And so I get here, this is equal to 4 times 1/4 squared is 1/16 minus 2 times 1/4 is 2/4. Let me multiply and divide here by 4. And so I get plus 4 over 4. 16 divided by 4 is 4. And so I get 1 over 4 minus 2 over 4 plus 4 over 4 is going to equal 3 over 4. And that is my vertex. Let me do problem number 50. Find the zeros in exercises 49 through 60. Find the zeros of the quadratic function. Use this information to describe the behavior of the parabola with respect to the x-axis. Okay, so let's find the zeros of my function. And so to find the zero of my function, I just set y equal to 0. Solve for x. Add 1 to both sides of your equation. So x minus 1 squared equals 1. By the square root property, x minus 1 is equal to plus or minus the square root of 1. And so x minus 1 equals plus or minus 1. Add 1 to both sides of my equation. So x is equal to 1 plus or minus 1. And so 1 minus 1, 0. 1 plus 1, 2. Okay. So let me do problem number 68. F of x equals negative x minus 1 squared minus 1. So let's find the vertex. Axis of symmetry. And so to find the axis of symmetry, I'll just set what's inside the square equal to 0. Add 1 to both sides of your equation. So x is equal to 1. Let's find the vertex. To find the vertex, I know the x-coordinate is just 1. Let's find the corresponding y-coordinate. So plugging in 1, 0 squared is 0, negate it, so you get 0 minus 1 is negative 1. So my vertex is at 1, negative 1. And let's sketch the graph of this. So notice here that A is equal to negative 1, which is less than 0, which means that parabola is down. A in absolute value is equal to 1, which means it has the same shape as the graph of y equaling x squared. And so if I sketch the graph of this, I get the following. So the vertex is at 1, -1. And it goes down, and it's -2, so it should look something like this. So this is the sketch of the graph. And here's my axis of symmetry. So my axis of symmetry is just x equal 1. And so that really finishes off section 14.2.